Howdy, howdy, this is Mr. Potter. Normally when we're printing material to the screen, the system out print or the system out print line is sufficient for us to do what we need to do. But sometimes we need to do a little bit more formatting, something more than just our normal escape characters will allow us to do. And so what we do is we have a command in Java called the printf command, and this is allows us to have a lot more control about how things are formatted. So I'm going to go ahead and create an empty class file. We're going to call this printf.java, just to kind of illustrate stuff. So public class printf and public static void main string args. And what's going to happen is, in general, the format of our command is going to be system.out.printf. And then in quotes, we're going to have stuff, and then we'll see a percentage sign, and then we'll see other data, which I'll talk about in just a minute. And all of that's closed inside of a string literal, and then comma, and then we'll have a value. And so what happens here is what actually comes after the percentage sign is we'll see something called flags, we'll see something called width, we'll see something called precision, and then we'll see another thing that says type of output. So we have to talk about what each of these things are. So the first thing I want to talk about is what are our flags that we'll be dealing with. So there's several flags that we have. I could put a minus sign, which means to left justify. Now normally what happens is that everything that I have will be right justified. If I put this minus sign up in front, it's going to make sure that everything is left justified. And I'll do examples of this in just a moment. If I have a plus sign, then what I'm doing is I want to output either if my number is positive or negative. Normally I only see the negative signs if my numbers are negative. I don't see a positive sign if my numbers are positive. So I'm going to see plus or minus for numerical values. If I put a 0, then what happens is that it pads the front of our output with zeros. So in other words, 1, 2, 3 becomes 0, 0, 1, 2, 3. So in other words, I'll see a bunch of zeros in the front of my data. I can also put a comma, which means that I'm going to do my comma grouping. So in other words, that's our hundreds, tens, ones place, hundreds, tens, and ones, millions, hundreds, tens, and ones, thousands, hundreds, tens, and ones. So our traditional comma every 3 digits, the way that we normally group. And if I have a space, then the space is going to display 9. So this is our traditional display minus if it's negative, no symbol if it's positive. So that's what we have for flags. For our width, this is actually talking about the width in characters of our output. So in other words, if I have a width of 8, then I'm going to see something that's 8 characters long, even if my value would not normally take 8 characters to display. So it kind of sets the width for what we're going to be dealing with. And again, I'll go through examples of this in just a moment. The next thing we're going to be talking about is precision. And so for precision, if I have decimals, then the question is how many decimal points are displayed. In other words, how many decimal places, I should say. So if I had a 5 for this, then I'm going to see 5 decimal places. Whether my answer has 5 decimal places or fewer, it's going to pad with zeros. If I have more than 5 decimal places, then it's going to truncate. So for decimals, I'm going to see how many of those, that's how many decimals are going to be displayed. For integers, in other words, how many digits are displayed. And for integers, if I have fewer than that number, then it's going to pad with zeros, kind of like what we were talking about earlier. If I have more than that many digits, then we'll talk about what happens there. And for strings, this is going to say how many characters are displayed. And again, I'm going to give examples of all of this. And then the final thing that we have is the type of output. In other words, what type of data are we dealing with for this value that we're going to be formatting? So if I see a D, that's going to be an integer. Now it seems counterintuitive because it should seem like D goes with decimals. If you think of D being the old symbol for pennies, the way that the British used to use the penny system, that's how I keep track of it, because you have a whole number of pennies. F is for floating point. In other words, your decimals, your floats, and other things that involve a decimal point. If I have an S, a lowercase s, and this is going to be a string, if I have a capital S, then what this does is this forces the entire thing to be capitalized. And if I have an N there, then this is going to force me to get a new line. So in other words, it's basically the same as the \n that we're used to. So this is how we're dealing with printf, and there's a lot of data here, and so the best way to go through this is just go through a ton of examples. So let's say I wanted to talk about formatting money. Now normally when I format money, I want it to 2 decimal places, even though I may be dealing with a whole amount of money. So what I would have is something like system.out.printf, and then I'd say the total is, and then I'd have a $sign to represent the total, and now I want to start my printf. So this is going to be comma, because I want the comma grouping, a decimal place because I do want decimals to show up, 2. So this 0.2 is my precision. In other words, I want 2 decimal places. And I'm dealing with floating points because money involved decimals. And then at the end of this, I'd force it to do a new line. So that's the end of my string literal. And what I can do is I can take the amount of money that I'm dealing with. So if I'm dealing with a $5,000 car, if I go ahead and run this, that's interesting. So let's say I have percentage sign, then a comma, then a 0.2, then an F, and then a %n. So let me force that to actually be a decimal. I may have thought that 500 was integer, and so it had problems. And so see, now it prints out the 5,000.00. If I was to deal with something like bananas, which were $2.98, then if I run this, it's going to print a comma space, but there are no commas that belong in there, so I just get 298. And so if I wanted to talk about buying gas, and let's say that I buy 70 gallons of gas at $3.29.9 each, I'd have a number that might have more than 2 decimal places. And what's important to note here is that my value ends up being rounded. So I've got that 0.895, rounds up to the nearest penny. If I try and run it with 0.894, then it ends up being truncated, just cut off. So what's nice about printf is that it rounds to the precision that we're looking at. Since I'm looking at 2 decimal places, then it's going to round to 2 decimal places precision. If I make that a 1, then what happens is going to round to 1 decimal place, and I should see 321.9. If I make that a 3, then I end up getting all of the decimal places here, and so I'll see the 0.894. So I can get a lot of formatting there. But of course, for our system, we typically use money with 2 decimal places. So to recap what we were talking about here, the percentage starts the formatting, the command. Then I see a comma, and the comma means we've got the HTO separation. And we saw that when we had a rather large amount that I would put a comma between the hundreds, tens, and ones place for each grouping of 3. Then we had the 0.2, which is 2 decimal places. And then the F means that we're dealing with decimals. And then the %n forces a new line. Because if I was to put another line here, like if I was to say system.out.printf, the taxes are, and then $, percentage, comma, 0.2, F, without the %n, and I wanted to put like 89,648. And then if I run that, it actually ends up concatenating it together. So notice that it gets this concatenation. The only way that I force it to actually move the next line of output to the new line would be that percentage sign in. So I really do want that percentage sign in there. So that's an example of how we deal with money. So the next thing I want to talk about is how to format a string. So what I'm going to do is I'm going to use the same command for 3 different strings and talk about what our output's going to look like. So I'm going to have system.out.printf, and then inside here, each of these are going to have the same thing. I'm going to see percentage sign 20.9s percent n, comma, and then I'm going to have a string afterwards. So what I'm going to do is I'm going to copy this line of code and I'm going to put different strings in here. I'm going to put hello world, I'm going to put toodles, and down here I'm going to put adios. Now I want to talk about what's happening here before I actually run this. Remember that percent starts the formatting, and then I've got this 20, so I'm going to have a space of 20 characters to write output. So in other words, I've basically got a 20 character wide box, but I'm only going to be using that 0.9. That 0.9 means only 9 characters will be shown, and this is going to be the right justified. And then of course, because I've got an S, means string. And our %n means new line. So if I run this, then I'm going to see hello world, toodles, and adios. Now this width here is 20 characters, but I'm only seeing the first 9 characters of each string. So I'm saying HELLO space WOR. I'm only seeing the first 9 characters of hello world, even though I've got a 20 character window for this. So this gives me a lot more control over what gets printed out onto the screen than %t would. Remember that %t would tab things over in multiples of 8. Here I can set how wide of a field I've got and how much of the word I'm actually going to see. So that gets a lot more control over what's going on. So the last thing that I want to talk about is I want to talk about formatting numbers. So I'm going to do system.out.printf, and I want to print the following. So I'm going to have %0 plus 8d %n, and I want to print 1, 2, 3, 4. And I want to do the same line of code with different values. So I'm going to do it again, this time with 1, 2, 3, and then I'm going to do it again with 1, 2, 3, 4, 5. Now, we talked about these things before. So the % starts the formatting. The plus is going to tell me that we're going to be output a plus sign or a minus sign depending on the value. So in other words, if I had all of these are positives, I should see a plus sign for each of these. The 8 means that we're going to have 8 characters long for the space. In other words, I'm going to be able to see 8 characters. And because I see this D, means I'm dealing with integers. And of course the %n is still a new line. If I run this, I'm going to see these aligned. And because I've got the 0 in front, I forgot to mention that 0 up here, that 0 means we pad the front with zeros. So as I see positive, because all of these are positive, 0, 0, 0, 1, 2, 3, 4. And I see positive 0, 0, 0, 1, 2, 3. And I see positive 0, 0, 1, 2, 3, 4, 5. Without the formatting, I would see 1, 2, 3, 4, then 1, 2, 3, then 1, 2, 3, 4, 5. These digits would be lined up as they are in my program. But because of the formatting, because it right justifies it, I see all of my ones placed lined up, and all of my tens placed lined up, and hundreds placed, and thousands placed. If I were to take this 0 and just get rid of it, It's not going to pad it with zeros, but it's still going to have 8 spaces out. And so I see that I've got 8 spaces here. The 5 for the number, the 1 for the plus, and then 2 spaces up in front to make sure this all adds up to 8. And if I was to add one more line here, I'm going to go ahead and copy this and paste. But if I were to make this a negative 1, 2, 3, 4, I'm going to see that this lines up exactly with the 1, 2, 3, 4 I've got here, but the difference is I see the minus sign instead of the plus sign. This plus makes sure that I see the sign of the number whether or not it's positive or negative. So printf is just one more tool in our arsenal to make sure that our output looks exactly the way we intended. It allows for a lot of precision in our formatting. It's a bit quirky at times, but it's very powerful, and it's definitely something worth learning. So once again, this is Mr. Potter. Thank you for watching. Have a great day.